The goal of the project is to create a motor control system that can be used to control a motor to rotate it in either the clockwise or counterclockwise direction. Here we see the potentiometer changing the direction of the motor as suggested. If an external load is applied to the motor and the motor speed decreases by 10% or more, the light will switch from green to red. Here we see Mark applying an external load. An additional quality control circuit is these two lights, which measure the direction. If the motor is rotating counterclockwise, the light is red, and if it's clockwise, the light is green.
So we have 18 plus 18 volts coming out of the voltage source and going through the resistor, which drops it down to plus 2.5 volts right here. It goes, because the Zener diodes have such low resistance, and at this point right here is 0 volts, the difference between the two is 2.5 volts. There's no current going through here, going through the potentiometer, because it has such a high resistance of 100K. The same thing applies to the bottom half of the diagram, but there's negative 18 volts going in, so therefore it's a voltage difference of minus 2.5.
All our chips have a maximum source voltage of 18 volts, and our system has to deal with higher voltages, so we assumed that 20.5 is about the highest we'd be dealing with. From this, we can say that this is 20.5, and after going through a Zener diode, it would be 18 volts before entering when it actually enters the chip. Same thing on the negative side. This would be minus 20.5, and this would be minus 18. We needed to pull a current through these resistors in order to have enough current to cause a voltage drop with the diodes. However, the power consumption was too large for a single resistor to handle. Our resistors are only rated at 1/4 watt, and we had a power dissipation of 0.54 watts. So we separated into 3 resistors. Each one can dissipate a 1/4 watt, and with the system we've set up, each one dissipates about 0.18 watts.
So we have the V command going into the instrumental amplifier, which comes out of the potentiometer. We have a resistive load right here that we calculated to be our gain to make sure that the motor is rotating at the speed that we want it to. The voltage now leaves the instrumental amplifier and goes into the voltage to current amplifier. This changes the voltage into current, which then goes into the motor. The tachometer measures the speed of the motor, and with that speed it outputs a voltage, which then goes back into the instrumental amplifier and causes there's a difference between the V command and V tach. When the motor slows down, the difference increases, which causes the voltage output to increase.
So what we have is the V tachometer. The voltage from the tachometer goes through a buffer so that no extra current is pulled. There's no extra resistive load from these resistors on the tachometer, which would throw off the voltages. It then goes through an absolute value amplifier so that our signals are positive. Simultaneously, we have to find 90% of VCMD. So we use this setup here. At this node, we end up getting 0.9 times VCMD, which then passes again through an absolute value amplifier. These two signals go through a comparator. The comparator compares the two input signals and measures the difference. If the difference is negative or positive, it shuts on or off. When the comparator turns off, it does not allow current to pass down to ground through it, forcing the voltage to go from this VS down through this diode, which is an LED light, turning it on. It goes into ground. Alternatively, if it does allow current down through it, then the current passing through either of these passes through this diode and through this diode being a green LED light. it then passes down to ground. It goes through this diode instead of this one because of a lower internal impedance. Similarly, the directional control works identically. However, our input signals on the two comparators are different. We compare VTAC in the directional monitoring circuit to ground.